Now, our next concept is mapping. All right, we've already looked at relation. We are moving on to mapping. So, what is a mapping at all? Now, we can say that a mapping is also a relation where each element in the domain assigns to only one element in the codomain. All right, we've already discussed about relations. I initially said that relation, mapping, and functions are related. Okay, so looking at the definition of mapping, you can say that mapping is also a relation. Okay, but you should take note that all mappings are relation, but not all relations are what? Mapping. Based on the definition, it says that a type of relation in which each element in the domain assigns to only one element in the domain. Now, when we're discussing the type of relation, we mentioned that some types of relation where we said some of them are assigned to where elements in the domain are assigned to only one. I know you've remembered those types of relation, and those type of relations are also called what? Mapping. Okay, so in that case, what are those types of relation we talked about? That where each element in the domain assigns to only one. Yes, so for this one we can think of what? One-to-one relation code. So when we say one-to-one relation, we can also say that it's also what? A mapping. So you can say one-to-one what? Mapping. Okay, because it must relate to only one element in the codomain. Okay, good. What other type can you think of? Yes, we also made mention of what? Many to one. Many to one. So the idea here is that element in the domain should relate to only one element in the domain, or the input should have a unique output. Each input should have a unique output. That is what we are saying. Okay, so we only have these two types of mapping, which are also what? Relation. That is one-to-one mapping, or many to one. Okay, so these are also types of mapping that we can look at, but that is not the main thing that we are going to look at. We are going to look at how we can find the rule of a given mapping. Okay, so that is what we are going to look at, not the types, because we've already discussed about the types in our previous lessons. So we are not going to waste time on that. We are only going to look at how we can find the rule of what? Mapping. Now, there are three aspects that we are going to look at how to find the rule of those aspects. Okay, so let's list those aspects and then we take them one after the other. All right, okay, good. So these are what's the three aspects that we are going to look at. So we are going to look at the rules of linear mapping and its reciprocal, exponential mapping, its reciprocal, and quadratic mapping. So we can have rules, or we can have linear mapping, exponential mapping, and quadratic mapping. So when you are asked to find the rules of such aspects, how you are going to do it, we are going to look at all of them. All right, but we shall take them, each of them. So let's look at linear mapping. What is linear mapping? Okay, so when we say linear mapping, we are saying that this is a mapping where the element of the domain have what? Common difference, as well as the element of the codomain having what? Common difference. So when you take the element, the independent variable, that is the domain, you realize that there will be a common difference among those elements. The same way, when you take the codomain, there will be a common difference among those elements. Now, in mapping, the domain is always represented by the x, that is the x-axis, and the codomain also represent what? The y-axis. Okay, good. Now, in a linear mapping and its reciprocal, this rule is given. We can be given this rule. So if you see this, we can say that this is what? Ax plus b. Ax plus b. Good. So we can use this as what? A rule for linear mapping. So when we ask you to find the rule of a linear mapping, this is what you use. This is the formula you are going to use. Now, where the a and b, as for the y and x, you know them because we are saying that they are so the y is the codomain and x is what? The domain. But the a, what does the a stand for? The a is what? The gradient, and the gradient of a slope or a slope of a line. Okay, this is a line. A linear mapping is a line. Okay, so this is the gradient. The a is the gradient or the slope of the line. And what does the b stand for? The b stand for what? The y-intercept. Okay, or it can be a constant. Okay, both the a and b are constant, but the b is what? Y-intercept. A is what? The slope or the gradient of the straight line. Okay, good. So we will not waste much time on this. We shall look at how we can find a rule of a linear mapping. Okay, all right, great. But before we take an example, let's look at how to find the gradient. Okay, so the gradient, which is the a, is given by change in y divided by change in x, which can be further expressed as y2 minus y1 divided by x2 minus x1. So when you find the difference, you find the difference of two elements of the y and divide by the difference of two elements of the x. That gives you what? The a, that is the gradient. Okay, so let's quickly look at this example, okay, and see how we can find the rule. So this is the example we are going to look at. Now, anytime you are asked to find the rule of a given mapping, what comes in mind is you need to ask yourself whether that given mapping is a linear mapping, exponential, or quadratic. Okay, so how do you determine whether the given mapping is linear? As I said, to find a linear mapping, the domain, which are the x values here, will have a common difference. Okay, the same way the codomain on the y-axis will also have a common difference. So you need to test a check and see. Okay, so let's see if we can have the common difference. So for difference, for my common difference, in x, let's see. So if I subtract 3 from 4, is it going to be the same as when I subtract 4 from 5? 4 from 5, or is it also going to be the same as when I subtract 5 from 6 and 6 from 7? Okay, so we know that this is, so here we get 4 minus 3 is 1, 4 minus 5 minus 4 is what? 1, 6 minus 5 is 1, and 7 minus 6 is also 1. So you realize that on the numerator, or the top one, which is the x-axis, we have common difference as 1. When you are done, don't end there, because you may think that because the x-axis has 1 as common difference, that is all. No, you also need to test for common difference in the y. Okay, so that one too, if you subtract 5 from 7, are you going to get the same thing if you subtract 7 from 9, or subtract 9 from 11, or subtract 11 from 13? Have you gotten that? Good. So 7 minus 5 gives us what? 2, which is equal to 9 minus 7 also gives us 2. 11 minus 9 also gives us what? 2. And then 13 minus 11 also gives us 2. So you realize that the codomain also have common difference. Once you realize that both the codomain and the domain all have what? Common difference, then it's a linear mapping. In that case, you need to find your slope, or your gradient, which is the a. So we need to find a. We said that the gradient, which is a, is giving us what? y2 minus y1 divided by x2 minus x1. Now what does this y2, y1, x2, x1, what do they represent? Now if you look at the mapping, you see that looking at the first value on the x, we can say it is x1, because that's the first. So if I move to 4 is what? x2, and then x3, x4. If I come to y, the first figure here becomes the the y1, y2, y3, y4. So if I can pick any number and their corresponding values, even though this one is what? x1, I can still pick 4 as my x1 and pick 5 as my x2. I can, the same way, I can pick 9 as my y1, 11 as my y2. Okay, so any value. In this case, I'm going to choose y1 as 5, y2 as what? 7, and then x1 as what? 3, because I chose 5 as y1, so I will choose it corresponding a value on the x axis, and then my x2 is also what is corresponding value for 7 is what? 4. Good. Once I choose that, then I can just do the substitution and find my value of a. All right, good. So y2 is 7 minus what is what? 5. Y1 is 5 divided by this 4. x2 is 4 minus x1 is what? 3, which gives me 2 divided by 1, and the answer is what? 2. So it means my gradient, therefore my a is equal to 2. Good. Now I can write the general rule. So the general rule given is what? Y is equal to ax plus b. I can substitute a for the general rule. Okay, so I'll write the general rule as y is equal to ax, where a is 2, so 2x plus b. Now we want to clear the b. How do we get the value for b? So what I will do is I will just go to the mapping and choose any 2 elements, okay, one from the x and one from what? the y, but they should be corresponding elements. So if I choose 3, then I must choose what? 5. If I choose 4, then I might choose 7. If I choose what? 5, then I must choose what? 9. Have you gotten that? So in this case, I'm going to choose y1, which is 5, and x1, which is 3. Okay, and do the substitution. So whatever I see y, I will put 5 there. Whatever I see x, I will put 3 there. Okay, so I can see that when y is equal to 5, x is equal to what? 3. Then I have 5 should be equal to 2. Then I'll put my 3 here plus b. Okay, good. So I'll do my simplification, which gives me 6 plus b. Okay, then I will do grouping of like terms. So b is equal to 5 minus 6, which gives me what? -1. So it means my b is -1. I can then write the general equation. This time I'm not going to write the whole general equation, but this is what I used. So I'm going to write this and substitute b this time. So I'm going to get y is equal to 2x. What is my b? B is -1. Now this becomes the rule for the given mapping. Have you gotten that? So it's very simple when you are asked to find the rule for linear mapping. That is how you go about it. Okay, all right, so this ends today's lesson. Let's continue next time. We shall be looking at rule for exponential mapping and quadratic mapping. I'm your facilitator, Evans Okai. The name of the channel is Mazris TV. You can search on your YouTube. Don't forget to subscribe to the channel for more videos. Like the videos and share. See you next time. Thank you.